Hello, and thank you for joining us for this month's public lecture. My name is Mitch Adelson, and I will be your host and moderator today. Before I introduce our speaker, I have several announcements to make. Next month's speaker will be Amy Yackel, a research geologist or ecologist at the Fort Collins Science Center, who will be talking to us about invasive species. So please join us on July 22nd at 7 p.m. Pacific Daylight Time. Some tips to turn on a couple of features on this platform. To turn on closed captioning on your desktop, click on the gear-shaped icon button located in the upper right-hand corner of the screen. Closed caption on your mobile device can be turned on by tapping on your phone and clicking on the closed caption TV icon located in the bottom right-hand corner of the screen. Towards the end of the lecture, we will open it up to questions and answer session. If you have a question for the speaker, you can submit them through the Q&A chat window. To find that chat window, look for the question mark icon in the upper right-hand corner of the screen. This will bring out a panel where you can type in your question. If you are on a mobile device, you can click on the question mark icon located on the upper right-hand corner of the screen and submit your question in the Ask a Question field box. Please understand that we may not have time to answer all the questions we receive, and we appreciate your understanding in advance. And now it's time to introduce you to our speaker. Carolyn Driedger's career began with the career with the USGS began in 1978 at the USGS Projects Office, Glaciology in Tacoma, Washington, with research on glaciers in the Pacific Northwest and Alaska. Many projects straddled the glacier volcano scientific disciplines. In 1986, she began a long-term study of glacier-related debris flows at Mount Rainier, and that project led to employment at the USGS Cascade Volcano Observatory, CVO. But it was her earlier witnessing of the May 18, 1980 eruption of Mount St. Helens and taking part in the response that set the course for the remainder of her career. This experience provided a front row seat and observation and reflection about the roles of science in society. As CVO's outreach coordinator, Carolyn has worked in partnership with public officials, emergency planners, news media, park interpreters, and educators to advance the cause of eruption preparedness. Some earlier career choices have informed Carolyn's current work, including several years of teaching school in the United States and in Kathmandu, Nepal, and also working for the National Park Service. Carolyn notes that her education continues every day through involvement in multi-agency partnership projects, and she credits her historian father for giving her the appreciation for examining the long-term impacts of events such as the eruption of Mount St. Helens. Carolyn, the floor is all yours.
Okay, thank you very much, Mitch. Can you hear me all right? Okay. Well, thank you everybody for being here. It's either a rainy evening or a very warm evening for many of us. Happy to be here and share this evening with you. Thanks for having me here today. As noted, I'm a hydrologist with the USGS Cascade Volcano Observatory in Vancouver, Washington. That's the little Vancouver that has the fenced fort here in Southwest Washington, just a stone's throw across the Columbia River from Portland, Oregon. So we're not the big gleaming city in British Columbia with the sea and the sky and the ski area nearby. And at CVO, we study volcanoes to learn about the eruptive potential of volcanoes. We keep watch over them by monitoring them. We communicate frequently with public officials and with the general public so that all of us can be prepared for the next eruption. Now, Mount St. Helens 1980 was a historic and landmark event that happened in our nation. No matter where we are tonight, I think we can all appreciate this extraordinary event. And I bet that if this were an on-site presentation, I'd guess that maybe half the hands in the room would go up, with people noting that, yes, they had been there, they'd witnessed it, they'd maybe worked there, or they had a family member who was involved. So I want to thank Will Seelig, Mitch Adelson, Christy Ryan, Ryan McClymont for inviting me, organizing and publicizing this, making sure that all the technical wheels are turning correctly. Thanks also to many of you in the Bay Area especially, who are long-term participants of this group. You know, your involvement has made this lecture series, what, a quarter century plus now, very successful and long lasting. And it's actually a privilege for any of us speakers to be a part of it. And so this is also a good time to acknowledge that the top-notch scientists who have responded to and studied Mount St. Helens over the years. We're not going to talk about a lot of geology tonight. We're talking about human context of the eruptions. So, but I do want to acknowledge them. You know, then I'll just mention a few names, and some of them might be familiar to you. And for every name that I mention, I mean, there are probably, you know, 100 other people who have been involved from the United States or around the world. Some names you might recognize, like Don Swanson and Steve Malone and Bob Tilling and Chris Newhall, Jim Valance and Rocky Crandall and Don Molyneux and Jim Moore and Pete Littman, and you know, still many people who continue to follow the events, many people at CVO and beyond, and the people who follow the hydrologic events and the ever-changing landscape that this landscape that continues to change even now, 41 years later. People like John Major and Kurt Spicer and many, many others. Okay, so you've heard that I started my career at the USGS in a research office, a project office, glaciology in Tacoma. I chose the study of glaciers because of all the geologic phenomena. It just seemed to me that watching glaciers was going to be probably the most dynamic of Earth process that I could actually ever witness. But I was wrong. And witnessing the May 18th, 1980 eruption of Mount St. Helens and taking part in that response just was, you know, it just packed years of education, years worth of education into, you know, a quick practical course and on how people respond to volcanic eruptions, how society responds. And it really set the direction of my work for the rest of my career. So as CVO's outreach coordinator for many years, I work in partnership with the groups mentioned, you know, lots of public officials, the news media, and educators, many target groups that can help the USGS get its message out about volcano hazards. Okay, so over the years, the geologic events have been pretty well chronicled in books and websites and videos. You've probably heard a lot about pyroclastic density currents and ignimbrites and such, but there's also a real human context to the story. It's not so often discussed. You know, for instance, you know, what are the factors of the time that influence the eruption response and its effectiveness? You know, what contemporary circumstances influence the outcome? What were people thinking at the time? What experience did they have that led them to the decisions that they ended up making? You know, it's really the connectedness of people and events and the personalities and their life experiences and that predispose the outcomes of a historical event. And I consider the response to Mount St. Helens a historical event. You know, additionally, I hope that today's talk will help you understand with a little bit greater clarity how science actually works. It's not all done in a lab. It's not all done even intentionally. Often it's human intuition. It's the mix of personalities and the coordination that takes place. You know, it's a march of previous events and our response to unique opportunities that arise. Sometimes it's just plain luck. So there are many ways in which the outcomes of an eruption response can happen. So therefore, it's really our job to utilize previous knowledge and to build a vision for the future, how we can best respond to a volcanic eruption. So we'll look at Mount St. Helens events as part of a long and ongoing continuum. Everything that the way that the response happened in 1980 was a result of what happened before, and what we're doing now will influence the responses to future eruptions. And so let's first of all, let's look at some events that influence our scientific eruption response and the collaborations and communication that happened. After that, we will look at how scientists and we'll look at how scientists and people in some adjacent professions were impacted. And Mount St. Helens did not just change the scientific world, it changed other professions as well. And then I'm going to show photos, some pictures of my experiences. And I say my experiences, that of myself, as well as my glaciology colleague, Mindy Brugman, who I was with May 17th and May 18th. That kind of set the stage for transition from glacier studies to that of volcanoes. Okay, and so first, it's important to recognize that how people all through human time have experienced volcanic eruptions, whether it be 79 AD or an eruption that's viewed by any culture. It's a really big deal. You know, eruptions can happen only once a generation or every few generations. And so in every culture, it tends to be remembered either in oral or written accounts. The native people living here in the Pacific Northwest left us with some amazing stories of volcanic eruptions in their own words. Perhaps they were the first to warn future generations. Some of the first outreach products might have been their oral traditions that were both very personal, very pointed, very descriptive. Some of those accounts are interesting to us even today. Now, let's just put yourself in the mind of one of those ancients who witnesses a volcanic eruption. All right, just imagine that ashes rising into the sky and the lava's flowing down the sides of the volcano. That eruption is basically a sensory overload. Imagine the smell of sulfur, the sight of the ash and lava, the sounds, the explosions, the feeling of the heat and the grittiness of the ash. All these things are major aspects of volcanic eruptions. Whoops, oh, sorry about that. There's often a lot of symbology associated with volcanic eruptions. You know, the land seems stable, but then it goes through big changes and magma's rising from the bowels of the earth. It's uncontrollable, and very often it causes harm, and there's a thought that maybe somebody did something wrong. So we have a better understanding of volcanoes today than many years ago, but I like to think that in my communications with the public that some of the same visceral reactions that early people have are experienced by people today, and that affects our approach and how we talk about eruptions. So there's a little bit of an offbeat book by Alan Weltzine, Exceptional Mountains. It's a cultural history of the Pacific Northwest volcanoes, and he has some interesting things to say about Pacific Northwesterners and our relationship to Cascade volcanoes. He says that Cascade volcanoes are like gleaming white magnets that pull crowds to their slopes. And he notes that each Cascade volcano has its own tributary region of population. So the regions use their approximate volcano to actually brand the identity of their community. And, you know, these volcanoes actually give a region a civic and personal identity. I've heard it said that these volcanoes, you know, are the spiritual and cultural icons of the Pacific Northwest. So, you know, at first they just appear like they're on the horizon. They look like a row of sentinels standing on the horizon. And if you fly westward to Western Washington, Oregon, Portland, Oregon, which is common for me, you know, I know that I'm almost home when I see those sentinels on the horizon. And they do seem very remote, but actually they are right in the middle of our lives, because when there is an eruption from one of them, they will affect everyone, and not just people close to the volcano, but in the entire region, and you know, and eventually resonating across the nation. And those are all factors that we need to consider when we talk to people about volcanoes, is that there's a very you know, emotional attraction to them. So let's put Mount St. Helens response in perspective a little bit and look at some of the history of it. The history of responses really began decades before the eruption of Mount St. Helens in a couple of ways. And first of all, we had volcanoes erupting in Hawaii. We had eruptions at Kilauea, as well as at Mauna Loa volcano. And so we had good scientists working there for many years trying to understand the best ways to monitor those volcanoes, understand how volcanoes work. And those are, for the most part, non-explosive volcanoes. And so people were employing methods that were appropriate for non-explosive volcanoes. Here in the Pacific Northwest, we had some USGS researchers studying, just doing the first iteration of mapping at Cascade Volcanoes and surrounding terrain. And for example, Rocky Crandall was one of them. Is Dwight Crandall is his full name, but known for many years as Rocky. Rocky was tasked back in the 1950s with mapping the glacial rock layers downstream of Mount Rainier. And he spent a lot of years with this. He was a very good field researcher, very careful researcher. He was looking at how those deposits had arrived in place. And he noticed something really peculiar. He said it was amazing because normally you would expected that a that a glacier would plaster the rocks on the valley walls as well as on the valley floors. That's what you would expect to see from Ice Age or later glaciers. But that's not what he was seeing. He was noticing something very different. He was noticing that these rocks look like they flowed into place, and that just didn't make a lot of sense. He and others in the United States, other volcano scientists, did not have that experience of seeing a mudflow or a lahar. He did seek alternative explanations, and just trying to understand what was going on. He's told us that for many years he wondered about this and wondered, he thought, what could have caused this layer to be in place, looking like it flowed into place. And then he said it was actually on July 25th, 1953, and he marked the moment in his field notebook that maybe there was a new idea. Maybe these had flowed into place. These deposits had flowed into place, and it was actually a mudflow that was the source. And he didn't really understand what the source might have been. Finally, following the breadcrumbs up valley, he reached Mount Rainier and realized, looking at the rocks as well, that this was from a massive debris avalanche and lahar from Mount Rainier volcano. And that insight at Mount Rainier, just north of Mount St. Helens, helped us to understand one of the many hazards at Mount St. Helens. Now, Rocky Crandall and his close colleague, Don Malone, were working somewhat simultaneously on 2 volcanoes and maybe more. They had a lot to do, busy people. And so at Mount St. Helens, they noticed some interesting things. For one thing, they realized that the volcano didn't have much vegetation growing on it. They realized that eruptions had happened relatively recently and with great frequency. And they realized by, again, following this time the airborne breadcrumbs, that the ash that they found on the slopes of Mount Rainier, the southern slopes of Mount Rainier, actually originated back at on Mount St. Helens. And that was just amazing. So they were able to look at the frequency, the approximate dates when the volcano had erupted, and they realized that, wow, we need to inform people. So in February of 1975, they wrote an article in the journal Science about Mount St. Helens, and there was an accompanying press release in February 27th, 1975. It said that dormant Mount St. Helens will erupt again, and that it may erupt again perhaps before the end of the century. Now that was 1975. Remember that a lot of people quote 1978. They did write a hazard assessment in 1978, 2 years before the eruption, that noted basically the same thing. But this was their first science article about it. Then in March, less than 1 month later, I think it was about 3 weeks later, increased steaming by an order of magnitude began at Mount Baker volcano up by the Canadian border. This was actually quite amazing because the there was a lot of snow and ice that melted. But mostly it was an opportunity for scientists of many disciplines to come together and talk and get to know one another. Ostensibly about Mount Baker. There was, Rocky Crandall, and there was Don Molyneux, these stratigraphers who studied the layers of previous eruptions. There was Don Swanson, who looked at volcanoes in many aspects. There was Mark Meyer, the glaciologist, who was looking at it. There was Steve Malone, the seismologist. There was David Frank, who looked at the thermodynamics, and others as well. So I've actually interviewed some of these people and asked, well, what did it mean that you were all working together 5 years before Mount St. Helens erupted? Steve Malone told me that, UW seismologist, that basically this was a dress rehearsal for Mount St. Helens, unknown at the time. Understand this was the first USGS response to heightened volcanic activity in the contiguous US since Lassen Peak erupted in 1917. It was a great time for introductions. It was an opportunity to recognize also how controversial a closure can be when you try to close off a recreational area in a region where people are perhaps pretty independent already. There can be major implications. And of course, now we know from many, many eruptions later, looking at them around the world, that every volcanic crisis turns into a little bit of a societal crisis as well. All right, so that was very fortuitous that those people met. There were other influences as well. There were some that came from the Caribbean. And the world of volcanology, the study of volcano science, is a relatively small community. It was even smaller back in the 1970s and in 1980. So everybody talked together. Fortunately, we had a good person at the Smithsonian, Dick Fisk, who attended some of these international volcanic eruptions. So consider that in Guadalupe volcano in the Caribbean in 1976, scientists had a lot of issues that they had ended up dealing with coordination among themselves and communication with many others, among themselves and with others. So here's a little bit of the stat list here. So as this eruption loomed, there was no coordination among scientists. It was an uncontrolled news media access area. There was minimal pre-eruption monitoring. It was very slow buildup of volcanic activity, so people were getting restless, although it did threaten some violent activity. Imagine that there are 25 scientists and multiple scientific teams giving different interpretations of what might be happening. And then the journalists all had unlimited access to all these different scientific groups. Throw into that the fact that as some additional analysis of the volcanic rocks were made, it was determined that we might have a very explosive eruption, and so there was a very controversial evacuation of 77,000 people. And anytime you evacuate people, you're looking at a very difficult situation. Now you have crowd control as well as volcano control to address. 1979, the nearby island of St. Vincent, another eruption threatened. And for this situation, the threat was a little bit more apparent. There was better coordination. There was a successful evacuation. Here's a stat sheet on it that now everybody had looked at what happened in Guadalupe. They recognized that, at Guadalupe, La Soufrière de Guadalupe, this disputes between scientists actually became the principal news media story, and nobody in 1979 wanted that to happen at St. Vincent. So maybe they overreacted a little bit. There had been a 1971 eruption there, so the populace was a little bit more believing that additional eruption could happen. There was a pretty quick buildup of activity, but there was only one coordinated scientific team, and so they gave one interpretation. It was presented through scientific consensus. It was very straightforward. Interestingly enough, though, only the governor was allowed to talk, and the governor relayed the science information from the scientists to the journalists. He spoke for everybody, so there was this single stream of information, and nobody was given access to the hazard area. So nobody was completely happy with this. It seemed an overreaction. One reporter did threaten to blow the whistle and say that there was a cover-up going on, and the governor just simply deported him. Now, in the United States, we were watching this, 1976, 79, what were we doing? We were watching a hostage crisis. We were watching, participating in the bicentennial in the United States in 1976. But the scientists were watching, and by the time 1980 rolled around, everyone in the scientific community was thinking about what had happened at these two volcanoes and realizing that neither was really ideal for how we would communicate during an eruption in the United States. Okay, let's move out of the Caribbean. Let's come back to maybe our favorite part of the planet, the West Coast, and go to Mount St. Helens. There it is in all its beauty over Spirit Lake. It was a favorite place for recreation and had been for many decades. The public officials maybe didn't recognize fully the hazards that were there. Let's see. Okay. And I should mention also that in 1978, with the hazard assessment for Mount St. Helens that had been released, Rocky Crandall and others did carry it around to public officials in Southwest Washington and at the state level and told them about this hazard, and everyone said, "Oh, great, thank you, thank you for this information. What is a pyroclastic flow?" Okay, well, thanks, we'll deal with this when we need to, and they opened their metal filing cabinets and filed the plan. So that was kind of interesting. So let's look at the stat sheet for Mount St. Helens in 1980, as people were recreating down at the base. And there was no place-based volcano observatory in the Cascade Range. There was really a minimal amount of communication with public officials, minimal volcano monitoring in the Cascade Range, and a no valid emergency plan that was, well exercised, no interagency communication plan, and no community education. And basically, the science and the scientific disciplines were somewhat siloed one from the other. The seismologists worked together, and the deformation group and on and on. All right, so what were we the people thinking in 1980? Well, we were mostly concerned with some pretty depressing news that was happening in the spring of 1980. And, we had the rescue, the aborted rescue mission to collect U.S. hostages being held in Iran. We had a major and uncontrolled influx of refugees from Cuba, and that was a very political issue. And maybe as much as anything, everyone was concerned with the TV show Dallas, and they were wondering who had shot JR. So it came as a little bit of a welcome diversion that there was a new and exciting drama that was coming when people heard about Mount St. Helens. Now, March 20th, 1980 is commonly given as the date when Mount St. Helens awakened with a flurry of earthquakes, although we look back on March 16th and we can see that there were earthquakes were maybe questionable as Mount St. Helens related at that time. UW, University of Washington seismologist Steve Malone says this was a time that we were just living on adrenaline. In preparing for this talk and some other presentations, I went back and interviewed Steve and half dozen more others from that era. He told me that, well, there's a whole side story that comes with Steve Malone, and maybe that will be for another telling. But overall, there are a lot of somewhat coincidences that happened. He had just ordered a lot of seismometers that he was planning to set out elsewhere in the Cascades, Washington and Oregon. On March 1st, the first of the relayed data seismometers went online. Although at Mount St. Helens, we still had an old-time seismometer that needed to have its records changed from time to time. So activity was fast and furious, and I actually remember that afternoon of March 20th because Steve Malone, knowing my supervisor, Mark Meyer, because they'd worked at Mount Baker together, he called Mark, and Mark relayed the information to us. He came walking down the hallway and said, guess what? We have a series of earthquakes at Mount St. Helens. It may lead to something and it may not, but we're going to do all that we can to help them. We're going to offer them the loan of equipment and our personnel. We will take aerial photos. We'll lend them our knowledge of the area and do everything that we can. So there's in the lower left-hand corner is one of those early photos taken by Austin Post or Bob Krimmel. And this shows the crack that formed across the crater on March 27th, actually split open in a pit crater you see on the left. Okay, so now we've talked about how some previous people's experience and the meeting at Mount Baker and the events in the Caribbean about poor coordination and communication or excess control had happened, and people had observed that and wondered how we would deal with an eruption in the contiguous United States. Well, so how did the threat of forest fires in the Gifford-Pinchot National Forest prepare us for a volcanic eruption? Fortunately, the Forest Service had a very, very high value stand of old growth cedar and Doug fir within the forest boundaries, and they treated that as a diamond treasure. They did not want to see that go up in flames or the money that would be reaped by selling that. So they were very, very careful with creating an incident command system of very efficient, effective command and control communication, everyone well trained and knowing their roles, having a practiced framework for how they would deal with a forest fire. And so when Mount St. Helens showed signs of activity, Don Molyneux and Rocky Crandall, some among Bob Christensen and many others, actually fit very well into their system. And the USGS scientists didn't have a system for coordination and communication, but the Forest Service did, and we fit it in it somewhat like a hand in a glove. Now, how did a crisis in Alaska prepare us for this eruption response? Well, and we can go here to USGS scientist David Johnston, and he had actually just been hired. He was just beginning to his stint as a full-time employee of the USGS. But in 1979, he'd had some harrowing experiences at Augustine Volcano in Alaska, and apparently he was on this island, this volcanic island, and he was supposed to be lifted off by a helicopter when the volcano threatened. The helicopter couldn't make it there, and so David was stuck there for a couple of days, it sounds like. Eventually, the helicopter lifted it off the island, but the threat of it all, and the sound of tephra landing on the roof of that metal roofed hut very much influenced him. And so he was very motivated. He was personally and emotionally motivated to speak about this eruption, or about eruption potential. And there you see him on the left, the co-spec device for measuring gases. And then on the right, you see him with Jeff Renner. And Jeff was another Midwestern import. David was from Illinois and Jeff was from Wisconsin. And so Jeff has told me that they just formed a real connection when they first met. And that was in 1975 at Mount Baker, where Jeff talked his King 5 TV Seattle managers into letting him go up to Mount Baker and learn all that he could about volcanoes, and Dave took the time to tell him what a lahar was, a pyroclastic flow, how a volcano worked, and how they could measure, how they could monitor a volcano. And he gave Jeff Renner books to read, recommendations and actual copies, I think. And so Jeff was just a natural to respond, from a natural representative from the news media to respond effectively in spring of 1980. And to me, that just shows the power of getting to know the news media in advance of a hazardous event like a volcanic eruption, because Jeff could be part of the broader communication plan to disseminate accurate and good information to the public. And he was not the only one. There were many others as well. Okay, so time went on, and 2.5 months later, after times of earthquakes, times of no earthquakes, the time during which a bulge was growing more than 6 feet a day on the north side of the volcano, and people were pondering how long it would take for that to release and what would happen when it did. The morning of May 18th, with no precursory activity, we had a magnitude 5.1 earthquake. Boom, 8:32 in the morning. The entire north side of Mount St. Helens slid away. A lateral blast lifted from the uncorked magma chamber and actually advanced across the debris avalanche to the north. Eventually, ash rose into the air in what we call a Plinian column, and that ash rose to about 80,000 feet within 15 minutes time. And within hours, we had a lot of dewatering of the debris avalanche and lahars moving down actually all sides of the volcano, the biggest on the west side of the volcano. So this was a big event that everyone was wondering about. They were wondering how it would, what would go on. All right, and let's look at what happened in society after that. And I look at some contemporary accounts in newspapers, and 41 years have gone by, but it brings the feeling right back when you read these accounts. And looking at this one in preparation for this presentation, it hit home because it just seemed very right on, describing the feeling. It said that the writer said that until 2 months ago, in the memory of every living person, Mount St. Helens, shimmering across Spirit Lake, stood as a ready symbol of benign and beautiful nature in the Pacific Northwest. The mountain never will symbolize that again to those who have seen the destruction that has been wrought, or to the thousands whose lives have been wrenched in these days, that bright, peaceful, and deceptive Sunday morning of May 18th, 1980. And it just seemed like, at that time, it seemed like, what everyone was in the Cold War era was fearing had happened. It wasn't an atomic bomb, but it was a bomb within the lives of everybody in the region. It wasn't just a matter of 57 lives being lost, but it was the mental fragility and emotional fragility of everyone who had assumed this was a stable planet. And something that was uncontrollable and that was unpredictable, seemed unpredictable as well. So everybody was on edge to some extent. Oh, for the scientist, the mood was, the whole array of emotions and intentions, all at once. There was amazement at what had happened. There was shock. Some of us had been up at the volcano the evening before. Many had worked there and had taken positions for observation many times in the previous months. There was a lot of sadness. But there's also a recognition that a lot of work had to be done, and recognition that more eruptions were to come. So in those days, weeks, months, years, now decades since 1988, Mount St. Helens has become the master teacher, an ideal lab for volcano studies. You know, imagine if the volcano that you're trying to study, and any mountain you're trying to study, all of a sudden the guts are torn from it, so you can see the entire interior with all the evidence of previous eruptions laid out in the rocky layers like pages of a book. It's a fantastic learning opportunity. This monitoring of the volcano and analysis of the deposits led to new insights that are applicable to the Cascades and at volcanoes around the world. Too many to enumerate here. All right, and then in response, in May of 1982, the USGS decided that it was time to stop just gathering people from Menlo Park and Denver and Hawaii. They decided to bring everybody to one place. And so it was not initially in this building. They've only been here since 2002. But it was in small office spaces and originally in the federal building in downtown Vancouver where we gathered. Now we have an observatory of approximately 90 people. There we are out front a year or two ago. By the way, next year will be the 40th anniversary of the USGS Cascades Volcano Observatory, and there will be some commemorative activity, so keep that in mind. Something that happened very early on was the scientists learned that the necessity of working across scientific disciplines, and so maybe the best analogy for those of you listeners who work in business, for example, are that the accountants work in one place and the equipment developers work in another place, and managers may be somewhere else. But in fact, it's much more useful if you can all work together, and so it is with volcanology. So we have Mark here with a stream gauging site, and Seth here with a spider that has all kinds of instruments on it, and maybe a little portable seismograph as well. I'm not sure. I think that might be Rick Hoblet there in this picture by Bill Rose at Michigan Tech, doing the field work, looking at the edge of a avalanche of hot rock and gas, a pyroclastic flow. And here we have people out doing surveying. So when all these people can work together and look at the larger picture based on the data that they have to give, that's when we can get the best assessments of what's going on. The residents and people elsewhere around the world gain a profound appreciation for the destructive power of volcanoes. So, for example, here is a bridge that was torn away. I've seen the bridge being torn away, probably you have as well, in numerous video clips, and now encased in concrete like lahar deposit. And people recognize that volcanic ash and lahars, that they are long-term hazards. For example, even today, dredging is still being considered. Dredging went on for parts of many decades. Now it's in the news that perhaps we need to do more dredging to get some of that lahar deposit that's worked its way downstream. We have to get that out of the river channel to stop flooding in the Kelso Longview area. Volcanic ash. It sticks around for many months and can cause a lot of disruption. It can be a health issue. The very first health studies regarding volcanic ash were done in eastern Washington, Idaho, Montana, after the eruption of Mount St. Helens. Okay. By the way, it's a big question. What do you do with all that leftover ash and lahar sediment? And if you drive up and down I-5, you can see some of those big dredging piles in place. There were new ideas and technologies that sparked a revolution in volcano monitoring, and that really affects our ability to provide volcano hazard warnings. If we are able to work efficiently, we can get our data back by having it sent to us rather than by our having to go and change data, data loggers, whatever, all the better. And scientist studies at Mount St. Helens and all volcanoes, the Cascade Ranges, led to new insights and a new generation of hazard assessments. And certainly one of the people who's spent time the longest at Mount St. Helens has been Mike Klin, who you see in the lower right corner of the big photo. And Mike is, he's probably done more to give us a full picture of what all has happened at Mount St. Helens over the millennia than about anyone. And then younger Heather Wright on the left, and Kevin Scott looking at deposits at Mount Rainier. Pretty soon after the initial work was done at Mount St. Helens, it was recognized that all we had to do was look to the north and look to the south, and we could see volcanoes as far as the eye could go, could see, and they needed attention as well. And it's quite likely that the same process that happened at Mount St. Helens could be hazards at other volcanoes as well. That really set everybody to work. Okay, so understanding volcano behavior led to new kinds of hazard analysis. For example, we're now able to look at where ash might travel by inputting NOAA weather data into a model. We can, and assuming a certain amount of ash will come out of the volcano, we can see where that ash plume will go. And we also have event trees, which were pretty much, for the most part, invented at and played with early on at Mount St. Helens, Chris Newhall being a lead on that. So you look at possibilities, you ask questions, and you look at everything that's happening, and then from there look at the probability that other behavior will evolve from the eruption. And it wasn't just geologists and volcano scientists, it was the ecologists. And they discovered over many years, even today, they have their plots out, their ecology plots, and measure the number of plants and look at the plant growth and types. They discovered this really barren landscape quickly transformed into a mosaic of new and thriving plants and animals. And perhaps most importantly, Mount St. Helens really inspired a new generation of volcanologists, and it really increased the international scientific cooperation. Now, if we would have people come to Mount St. Helens from abroad, they would learn about our volcano and they would invite us to their eruptions. And so there was just this proliferation of new knowledge about how to monitor volcanoes, what happens during an eruption, just overall. In the Volcano Disaster Assistance Program, is an international group that is headquartered at the CVO. It's responded to more than 70 volcanic crises worldwide, and that has really strengthened the response to eruptions in about a dozen nations. And scientists and public officials, here in the Cascades, we've formed these volcano hazard working groups where we create a plan, we exercise the plan, and then we modify the plan to make it better. And these plans, these coordination or response plans, describe the roles of all these different officials. And here you can see one of our emergency managers from the city of Puyallup who has organized an evacuation, a lahar evacuation drill for parts of the Puyallup Valley. And I think 8,000 school children were evacuated in this drill in 2018. Right. So between 2013 and the present, the USGS, supported by the Office of Foreign Disaster Assistance, USAID, has supported binational exchanges where we bring officials from Colombia and Ecuador to the United States so they can study how we are planning for an eruption response. And we take public officials there. In 1985, there was a major eruption at Nevada de Ruiz volcano in Colombia where 25,000 people lost their lives due to a lahar. 25,000 people. And going to Colombia and meeting with the people, like this, for example, this gentleman who was the first one to fly over the region of Armero, this site of the destroyed city. He flew over early in the morning. Listen to him talk, really inspired all of us as scientists and our partners in emergency management to be ready for eruptions here in the Cascade Range. And we also try to increase awareness by taking a multi-agency approach. We work with targeted groups, policymakers, community educators, and news media, parks, champions in communities, and they try to get them the information that they need so that we can all work together and give consistent messages about these volcanoes. Of course, we had a boom again in 2004 and another eruption at Mount St. Helens that lasted for 3.5 years. And by that time, we were a little more experienced. We were able to handle what happened within just another major assault of news media. Okay, I mentioned that in some adjacent professions, those professions were affected as well. Steve Malone noted the acceleration of new equipment use and how what we learned at Mount St. Helens is useful at volcanoes around the world. It was a career-defining moment for many people. Retired emergency manager Bill Loki told me that in emergency management, we can draw a direct line from lessons learned at Mount St. Helens to our current volcano hazard planning efforts at other Cascade volcanoes. Retired King news meteorologist Jeff Renner told me that Mount St. Helens reawakening, the ultimate eruption and public fascination in that ongoing story led Northwest journalism to evolve in a way that encouraged strong science and environmental reporting for decades to come. He said that they felt like they had a real responsibility to get the story right. Retired NOAA warning coordination meteorologist for the National Weather Service, Ted Beener, told me that there was no volcano code for aviators in 1980. So pilots were warned about dust in the air, which of course is a completely different consistency from volcanic ash. But the National Weather Service and the USGS now work in close coordination to inform pilots about conditions and in a variety of ways during volcanic eruptions. In 1982, Congress finally acted to preserve the Mount St. Helens as a unique volcanic landscape. Since the 1930s, people had been trying to protect Mount St. Helens, and it had been a tough row to hoe. And finally, the interest was there in 1980 and 82. We had the formation of Mount St. Helens National Volcanic Monument. So now there are many opportunities for visits and learning. They exist today. Now I want to tell you for a few minutes of my experience and that of my colleague, Dr. Mindy Brugman. And because Mindy is the reason I was there on May 17th on the north side of Mount St. Helens in the first place. So Mindy was a grad student at Caltech, and she was studying Mount St. Helens. She had been doing it even before the volcano reawakened, but now her work began a new direction to look at the effect of a warming volcano on the glaciers on its side. So Mindy asked for some help, and she asked if I would be willing to come down to Mount St. Helens and help her for a couple of days. We went down on the morning of May 17th, I guess the afternoon of May 17th. Here's Mindy looking at a time-lapse camera set up at Coldwater 2 observation site. And there's myself observing the time-lapse camera with the bulge in the foreground. I think as glaciologists, we didn't have a full understanding of the forces that might influence us at that time if the volcano erupted. Harry Glicken is directing the volcano from the director's chair. And Mindy's examining the glaciology office's laser ranger that she had delivered earlier at the request of our manager, Mark Meyer. And the intention was to look at the bulge and how much it was growing. Here's David Johnston catching up on field notes that afternoon. I think this is the last picture taken of him. May 17th, around 9 o'clock in the evening. Well, while we were all sitting there talking, David, we had a lot of chit chat, and David said, I think this isn't the safest place to be, and I feel like, I really need to be here. Somebody needs to be here. I need to stay here, but we should have not too many people here. Let's have as few as possible. So why don't you, Mindy and Carolyn and Harry, leave, then come back and get a ride on the helicopter the next day. And so reluctantly, we put our gear back in the car and we drove back down to Vancouver. And this is a State Route 504. And you can see Mount St. Helens. This is probably one of the last pictures that was taken of Mount St. Helens in full form late in the evening of May 17th. And so we stayed at the inn in Vancouver, and we attended the Sunday morning 7 a.m. meeting, and where everybody talked about what activities they were going to do. I remember one thing that Dan Miller said, that he was going to be going up that day, and he was going to attend to seeing that perhaps a military tank could be put up at Coldwater 2 as a place of safety. He drove up I-5. Mindy Brugman and I were a few minutes behind him on our way to Mount St. Helens as well. And somewhere between La Center and Ridgefield on Interstate 5, Mindy and I noticed a black cloud forming on the north side of the volcano and progressing northward. You know, it was moving up towards the hills of the Mount Margaret area, moving obliquely away from us. There it was, and we did not know what it was at first. And finally we realized. We went back to Vancouver and began addressing the news media. Dan Miller would get the information from people out in the field. We would assemble it as talking points and deliver it. It was a very sobering time, a no food day. And people said, you know, Dick Fisk was at La Soufrière de Guadeloupe and at St. Vincent, and he's going to give us some advice on how we handle the news media. So between Dick's advice and our working within the structure of the Forest Service, we worked as best we could to have a successful response. These are just a couple of other photos that I have of Mindy in the office and of people, Richard Waite and Keith Stoffel, and I think that's Don Swanson in the lower left-hand corner. Okay, so as with these drivers on I-5, we all had to learn to adjust, you know, from viewing volcanoes as benign to features that could harm, you know, from being isolated, doing isolating monitoring, to having full networks, full arrays of monitoring data, from scientists siloing in our offices to working in partnership to address societal need, and from isolation with emergency managers to planning with them, and from news media avoidance to actually working with the news media and educating them, and from accepting an uneducated public to educating that public. There are lots of resources that you can go to learn more about Cascade Volcanoes. There's social media. There's actually an update that comes out every Friday that tells what's going on in the Cascade Range. Additionally, for the 40th anniversary, we created a fact sheet, 10 ways that Mount St. Helens changed our world. And it's online. We also have probably a few thousand copies to deliver, since most of our or actually all of our on-site 40th anniversary events were canceled due to the pandemic last year. So if you want to learn more about this, how Mount St. Helens changed things, take a look at that fact sheet. Thank you, and I hope that you enjoyed this, and I hope you had a good evening.
Thank you, Carolyn. That was a great talk. We are now open for question and answer portion of the lecture. Have been monitoring questions that have come through and have captured all similar ones together, and I will ask those out loud first. First question from someone is, on that day in March 1980, when your supervisor Mark came down the corridor with news of Steve's phone call about the waking of Mount St. Helens, did your heart go into your mouth, knowing what it could lead to?
Total disbelief. We were on the 8th floor of the Pacific Bank building, south side. We later on were able to see eruptions of Mount St. Helens, but on that rainy day, with clouds in the sky and rain beating against the windows, it seemed like an impossibility. And it also seemed like, well, why would we be the ones privileged to see this in our lifetime.
Okay. Another question is, when I visited Seattle, I was amazed to see how close Mount Rainier is to this city. Do you fear what might happen there?
Mount Rainier is, yes, it's close to Seattle, but it's also much closer to a lot of other good communities in the southern Puget Sound area. Those are the communities that are most at risk, and they're the ones that we work with to the greatest extent. A lot of the terrain in the valleys of the southern Puget Sound area were once part of Puget Sound. They were filled in part by these large lahar over the millennia. These areas were filled in. So we're very familiar with the hazards to that area, and that's what we're most concerned with. Seattle itself, Tacoma, both cities are up on the hill. The ports of those cities are both at risk. And of course, we do work with King County and the people in the city of Seattle, but it's mostly, you know, the people in the Puyallup Valley of the city of Ording and Puyallup, Sumner, all good folks who have really taken this to heart. You know, we went in there in 1993 and we talked to it wasn't me, I wasn't involved at the time, but some of my colleagues, Ed Wolf and Steve Brantley and others went to the community and said, you know, you have a problem here, public officials. We have this threat from Mount Rainier. I know you see it. I know it's on your city emblem, but it's also a threat because mud could come down here and bury this entire area. And to their credit, they have taken it to heart and made that threat a part of their school learning. Ording and Puyallup both have evacuation drills, and there's going to be a very larger evacuation drill next year, apparently. And they have accepted that they have this threat, and there's no more lahar-ready city than perhaps Puyallup and Ording.
Okay, one other question. There were follow-up quakes all the way south to Mammoth Mountain. My husband and I were honeymooning in Yosemite at the time. Were there fears that other mountains would explode or erupt at that time?
There were earthquakes at Mammoth Mountain. There were earthquakes at Mount Hood also. And so I think it was very tempting for people to make a connection. I'm not sure that any physical connection ever has been drawn. There may be some that I'm not aware of, but yes, we were very concerned and feeling on pins and needles because we had a lot of people, a lot of emergency managers and members of the public who were not at that time ready to deal with a volcanic eruption. But Mammoth, lovely, isn't it? I was just down there last week.
Yeah, no, I haven't been to Mammoth in years. I need to get out of the pandemic mode and go traveling again. Give people a couple more minutes. We don't have any questions in the queue at the moment. I'll give people a minute or so if they have any last minute questions they want to ask. I will remind the audience that next month's lecture will be on July 22nd at 7 p.m. and our speaker will be Amy Yackel, who will be talking about endangered species. I will also remind everyone that these lectures are archived, and if you want to go back and watch this one or the talk about Mount Pinatubo or any other lectures that we have, they are all available to watch. So please go to the www.usgs.gov/PLS and check the archived lectures. Okay, a couple more questions. One is, what happened at Guadalupe after the 77,000 person evacuation? Was there an eruption?
Good question. I'd have to go back and look. There was not an eruption that kept people evacuated. people basically, decided they had to go back. But what precipitated that was that people thought they saw volcanic glass within a rock sample, which, could indicate maybe some higher explosivity. I'd have to go back and look, but I don't think there was sufficient activity that warranted, 77. But if it had been a more explosive eruption, then it would have been highly warranted. So people are doing a little bit of historical going back and rethinking it all a little, saying, well, maybe it wasn't completely for naught. And it could have been worse. And, of course, sometimes that's a reason enough in itself to evacuate people, but certainly no massive eruption. But I just can't remember the exact extent of what did happen.
Okay. Another question is, does the politicalization of science concern you about preparedness?
What is the noun there?
The politicalization? Oh. Sorry, I couldn't get my mouth around that one.
Does it concern me? Of course. But at the same time, people are, think freely, and probably all for human time, science has not been accepted right away. And in many cases, they've been thought of as, being, not being accurate in their predictions and such. So I think we just have to look at it that way. And I'm actually amazed to look at all my scientific colleagues and look at them in volcanology as well as in glaciology, and people really, they keep their nose to the grindstone and their shoulder to the wheel, and they really don't let the political winds influence them too much. They just do what they have to do. And if you know scientists, you might understand that they have that capability to be very focused and to not let the winds of political change or politicization influence them overly. They stick to their work.
Most assuredly. Follow-up question from the woman who asked about Mammoth Mountain. She said there were slides in Yosemite Valley and the trails were closed. It was rather exciting to be on that, to say the least. And yeah, slides happen in Yosemite all the time. So it's something that occurs, I believe it. Pretty regularly. In fact, we have a public lecture about rock slides in Yosemite you can go back and watch.
Oh, interesting. I bet that was very exciting. And you had a chance to witness some of the really dynamic processes that happen in on Earth. And that's, John Muir would tell you that was a good thing, right?
Yes, he would. Let's see. Sorry, there are a bunch of questions. I'm just trying to go through and see if there's any kind of common themes here. Wants to know if Mammoth area is still seismically active.
Can the Mammoth area?
Is it still seismically active?
Okay. Well, that's not my area of expertise, but I do know that earthquakes, do happen there, and there have been some fairly large ones. I would suggest that you go to the website for the USGS, California Volcano Observatory, CalVO. If you just do a browse on USGS, Mammoth Lakes, California Volcano Observatory, all those events are listed, and certainly many things that are not in everyone's memory all the time, but they are interesting nonetheless.
Okay. Somebody's asking if they think that Mount St. Helens will erupt anytime in the next 10 years.
I'm not going to place a bet on 10 years, but one thing that's been noticed is that when one of the volcanoes is on a roll, we can say with some degree of reason, that it's most likely that it will be the next one to erupt. And so that certainly is a possibility. There are different points of view on this. Some people say, yes, that could happen. And other people say, well, maybe we don't have the magma below. Now, there's evidence that there's not sufficient magma beneath in the magma chamber to cause trouble there. And so, we're just going to have to wait and see. That's one of the interesting things about the volcanology. You can't always experiment, but you have to just observe and be an intelligent observer. And so that is our mode of operation in terms of thinking about long-term forecast.
Okay, a couple more questions. One was, what kind of debate was going on in the USGS in 1980 about the probability of lahars versus quieter lava flows?
Well, that's a good question, and I'm not sure if I have the answer, but I think that overall, and I don't know if that's somebody in the know who is asking that question, and certainly lava flows are better known than lahars. There was a lot of debate as to what might happen with the bulge, and there were some theories that had been put out there. There was just a lot of debate going on overall. Remember that we had a group of stratigraphers looking at the layers of previous eruptions. We had people working with quieter volcanoes in Hawaii. We had people who were landslide specialists. We didn't have people with a lot of just full-bodied experience. So I can't tell you what people were thinking in terms of that, and maybe they can. But lahars are lesser known, but probably in the end are more destructive than lava flows at Mount St. Helens anyway.
Right, okay. Couple more questions. I think we'll call it an evening. Have there been what have subsequent slope failures in Mount St. Helens looked like? Does lahar leftover material remain highly mobile?
That's a good question. That's a very relevant question too, because just a few weeks ago, we were looking at the webcam that is set up at the Johnston Ridge Observatory, which is my background and here in the picture. And Kurt Spicer said, there has been a huge slump that happened, and we lost a lot of activity down into the Toutle River. So he and others were going to watch and see if it made its way downstream. But yeah, some of it is saturated and others is not. There's a lot of porous rock there too, so maybe not a lot of water sitting at the surface. And of course, we're also always looking at the external slopes of Mount St. Helens via our GPS units as well. We do not see any kind of slumping happening of the volcanic edifice itself.
Okay, one other question, and we can maybe close it as you started your career. It says, as a glaciologist, how excited are you with how the Crater Glacier has been doing in its formation and sustainment?
Oh, go Crater Glacier. Yeah, this little glacier has real oomph. And it was born under very fortunate circumstances. Pretty much all the glaciers of the western United States are in recession and are thinning right now. But Crater Glacier is that exception, where it was born in a volcanic crater due to the avalanching of ice, of snow, and of rock, creating a very rock-rich glacier. And not only that, but it was formed in the shadow of that horseshoe-shaped crater, and so it just picked up a lot of thickness. It became very thick. We wondered what was going to happen in 2004 with the eruption. We thought, well, it was so amazing to fly around in a helicopter and to see this spine of fresh lava dome rock piercing through the ice. And we were all a little bit aghast at that, at least those of us with glacier affinities. And as that lava dome grew and grew and grew, we watched the glacier respond where, you know, it just didn't melt away. It was only like about 5–6% of the glacier was melted during the 2004 eruption. But instead, it just picked itself up and it boogied up those inner side walls of the crater. It buckled up there, and it's rigid ice. And then it got high enough, it was very thick, so that it's been making a fast zoom down to the north and out the crater breach. But it's getting pretty adventurous and pretty spunky, and it's moved out onto the sunny plain outside of the breach of Mount St. Helens. So with that kind of behavior, we don't know, how long that advance is going to last. I think the advance itself is actually pretty much, slowed to a halt. We'll have to look at the latest numbers on that. So, but yes, it's pretty exciting to be watching Crater Glacier.
Okay. Thank you again, Carolyn, for your talk today and for answering all the questions from our audience. And also thank you to all you joining us today. This lecture will be available later for on-demand viewing at our website at www.usgs.gov/PLS. And we hope to see you next month on July 22nd for our talk on endangered species by Amy Yackel. Have a good evening, everyone.